Hello everyone, welcome back to ANR Academy. This is Nepal Eddy sir. Today we are going to learn the formula to find number of reflexive relations from given set A to itself. Before going to discuss that, first let us see the number of subsets of given set A, and after that number of relations from A to A, and then reflexive relation definition, and after that let us discuss number of reflexive relations from A to A. Yes, first one, how to find number of subset to a given set. I am going to select an example. Let us suppose a set capital A that containing entries only 1 and 2. Another set I am going to consider B having entries small a, small b and small c. Now write subsets of A and subsets of B. I am going to write subsets of A. Suppose if I select a set with 0 entry, a set with no entries, every empty set is subset of given set. Next, the set containing only one element, there is a chance to write set containing element 1, set containing element 2. Set doesn't contain any element, set containing only one element. Next, set containing two elements, there is only one chance, that is set of 1, 2. Now let us count how many subsets you have here. There are totally 1, 2, 3, 4 subsets are there. So number of subsets total 4, and this is written as 2 power 2. Here base value 2 and exponent, it indicates number of elements in the given set, that is n of A. The same here, suppose that here if you write subsets of second set B, set containing no element, that is empty set subset itself, empty set subset of given set. Next, sets containing only one element, that is set A, set containing B, set containing C. Next, sets containing two entries, A comma B, B comma C, A comma C. Next, the set containing all the entries, every set subset itself. Now count total number of subsets of second set B. 1, 2, 3, 4, 5, 6, 7, 8. So total we got 8 subsets, and it can be written as 2 to the power of 3. Here base value 2 and exponent 3, that is number of elements in the given set. So that here I can write n of B. So it is very clear that number of subsets of given set formula 2 to the power of number of elements in the given set. Next we are going to learn number of relations from A to A. Suppose A is a set having entries 1, 2. I am going to write A cross A first. A cross A, that is a set of order pairs from the given set capital A. I am going to write possible order pairs, that is 1 comma 1, 2 comma 2, 1 comma 2. A related, there is a relation from A to A. A having entries 1 comma 2. So that 1 1 1 2, 2 1 2 2. One more entry you have to write 2 comma 1. So total there are 4 order pairs which are in the set A cross A. Yes, this is about cross product of two sets. Next, number of relations from A to A. Relation is nothing but every subset of A cross A is called a relation. There may be a null relation or maybe a only one element related to another element, different cases. So that how can you define a relation? Relation is every subset of A cross A is a relation. You know the definition. So by the definition, every subset of A cross A is a relation means total number of relations, indicates total number of subsets of A cross A. So that here I am writing number of relations. Now I can write equal to number of subsets of A cross A in this case, number of subsets to a given set, formula 2 to the power of number of entries in that set. So here base value 2, number of entries in A cross A, that is 2 to the power of, here the number of entries 1, 2, 3, 4, 2 to the power of 4. So the formula 2 power number of elements in A cross A. Remember, relation is nothing but every subset of A cross A. So that number of relations written as number of subsets of A cross A. So that 2 power n of A cross A, number of elements in A cross A. That is the formula. So this is about number of relations from A to A. Now let us discuss what is reflexive relation from given set to itself. Yes, suppose that capital A is a set containing entries 1, 2, 3, and there is a relation from A to A, that is itself. Now let us discuss what is reflexive relation. The relation is called reflexive if suppose A comma A belongs to that relation for all small a belongs to that given set. Small a is the element from set capital A. If order pair A comma A belongs to R, for all A belongs to A. Here ordinate and abscissa both are same in case of reflexive. A comma A if present in the relation for all A belongs to A, then it is reflexive relation. And what about the other entries? That is, suppose here A having entries 1, 2, 3, it is must 1, 1, 2, 2, 3, 3 should be in the relation, and remaining 1, 2, 1, 3, 2 3, 2 1, 3 2, 3 1, like that. They are may or may not present in the relation. Just you have to remember that the relation is said to be reflexive. Diagonal entries must be present in the relation, and the other elements may or may not present. Let us see what are diagonal entries and the other entries. Since there is a relation from A to A, 1, 2, 3 entries from A, 1, 2, 3 entries from another A. Now the possible order pairs I am going to write. 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. These are set of values of A cross A. There is a relation from A to A, and here the entries 1, 1, 2, 2, 3, 3, particularly these three are called diagonal entries. These are diagonal entries, and the remaining are non-diagonal entries. Here the definition: a relation is said to be reflexive that must contain order pair A, A for all A belongs to A. That is, for all A belongs to A means for 1, 2, 3, there must be order pair 1, 1, 2, 2, 3, 3. That is must. And what about the non-diagonals? There is no condition for non-diagonals. They may be present or may not be present in the relation. If all the three present, then we can say that the relation is reflexive. For example, I am going to write a relation here, R1, that containing entries 1, 1, 2, 2, 3, 3, and I am going to write 1, 3, 2, 1. Here, just cross check whether 1, 1, 2, 2, 3, 3 present in the relation or not. Yes, diagonals are present. That's all. If diagonals present in the relation, then it is reflexive. For other entries, just remember that they may be present, they may not be present. Next, one more example I am going to write. Suppose that R2, another relation having entries 1, 1, 2, 2, 1, 3, 3, 1. Here only two diagonals are here, but there is no 3, 3. Here the definition: for all entries, the pair must be of this form A, A, but there is no 3, 3, so that it is not reflexive. So that is finally, whatever the entries we have in the given set, the same number present in the first coordinate and in the second coordinate. That is for all the elements. Remember, if all the entries, principal diagonal entries, are in the relation, just decide that the relation is reflexive. Don't bother about the other entries. Other entries may or may not. Okay. Now let us move how to find number of reflexive relations from A to A. Yes. See here. Suppose that capital A is a set that containing entries 1, 2, 3 and so on n. Therefore, I can write number of entries in the set A is small n. Now, I am going to write A cross A. A cross A that contain entries 1 1, 2 2, 3 3 and so on n comma n, also 1 comma 2, 1 comma 3 and so on 1 comma n. Similarly 2 comma 1, 2 comma 3 and so on 2 comma n, like that up to n comma 1 and so on n comma n minus 1. Let us see A cross A. Here there is a relation from A to A. Suppose the entries 1, 2 and so on n. Here 1, 2 and so on n. Order pairs 1 comma 1, 1 comma 2, 1 comma n. Next here 2 comma 1, 2 comma 2 and so on 2 comma n. Here n comma 1, n comma 2 and so on n comma n. These are all set of values, set of order pairs in A cross A. A relation is said to be reflexive. We know that all the principal diagonal elements must be present in the given set. That is, it is must to write 1 comma 1, 2 comma 2 and so on n comma n, and the remaining entries may or may not. That is next non-diagonals. This is exceptional case. But this is must. So now let us observe how to find number of relations. You know that number of reflexive relations. We know that a relation is said to be reflexive that must contain diagonal elements, so that there is only one chance to write diagonal elements. So number of reflexive relations I am going to write. This is must. So compulsory you have to write principal diagonal elements, so that number of ways to write principal diagonal elements, there is only one chance. Next, non-diagonal entries. Total there are n square elements, total n square, and here diagonals are n and non-diagonals are n square minus n. So non-diagonals, next we are going to discuss number of ways of writing non-diagonal entries. Non-diagonal entries we have n square minus n. They may be present or may not be present in the relation, so that there is a chance without writing non-diagonals or with writing with writing non-diagonal entries only with one non-diagonal entry. And another possibility, diagonals must, and then non-diagonals only 2, next only 3, only 4, up to non-diagonals n square minus n. Here number of reflexive relations in which the condition it is must to write diagonal elements, that is one chance. Non-diagonal elements may or may not present you have, so that there is a chance for 0 entries, only one non-diagonal entry, next two non-diagonal entries, next three non-diagonal entries, and so on up to n square minus n non-diagonal entries. One non-diagonal means you may write 1 comma 2, 2 comma 1, n comma 2, 1 comma n, whatever. So such type of chances are there. Next, diagonals must only with two non-diagonals also you can frame relations. Two non-diagonals, maybe you can select 1 comma 2, 2 comma 1, or n comma 1, n comma 2. Like that there exist many relations. So the chances to write non-diagonal entries total, that is, you have here there are n square minus n chances, and hence 2 to the power of n square minus n indicates here the relations. Why? Because you know the definition of subset and number of subsets. If there is a chance to write non-diagonals, there is, suppose that this is the case without non-diagonals, only one order pair along with diagonals, that chances. Next, two order pairs along with diagonals, another chance. Suppose three order pairs along with diagonals. So like that, how many chances are there? 2 to the power of number of elements in that set. The same here, I am going to write 2 to the power of number of elements in the non-diagonals. So that finally 1 multiplied by 2 to the power of n square minus n implies I can write the number of reflexive relations formula 2 power n square minus n. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to like, share and comment. Thank you so much.